Hello and welcome back to this course on OpenCV 4 for secret agents. In the previous section, we helped Benji identify enemy's messenger by classifying images. Now our secret agent Benji finds out that the enemy has hidden a bomb in an object. He has to go through hours of surveillance video to find the object. Let's help Benji ease this process by building him an object detector. We're going to do that by learning some basics of object detection, see some common techniques, and then use one of those techniques to build our object detector. So first up, fundamentals of object detection. Some of the most common tasks in computer vision are image classification, object localization, and multiple object detection. Image classification is the most common computer vision problem where an algorithm looks at an image and classifies the object in it. It has a wide variety of applications ranging from face detection on social networks to cancer detection in medicine. Such problems are typically modeled using convolutional neural net. This is something that we saw in the previous section. Let's say we not only want to know whether there is a cat in the image, but we also want to know where exactly the cat is. That's an object localization problem. Object localization algorithms not only label the class of an object, but also draw a bounding box around the position of that object. So that's localization. But what if there are multiple objects in the image, like in the third image shown here? And we want to detect all of the objects, right? So that would be an object detection and localization problem. So not only should you be detecting one object, but you have to be detecting all the objects in the image and put a bounding box around all the objects in the image. A well-known application of this is in the self-driving cars, where the algorithm not only needs to detect cars but also pedestrians, motorcycles, trees, and other objects in the frame. These kind of problems need to leverage the idea or concept learned from image classification as well as from object localization. Object detection is a very useful technique. Some of its uses include face detection, whether it is smart cameras trying to focus on our face or trying to detect people on surveillance cameras. Face detectors are very useful. Another simple application is counting. The ability to count people, cars, or flowers, or even microorganisms is a real-world need that is broadly required for different types of systems using images. Another interesting application is the visual search engine of Pinterest. So they use object detection as part of the pipeline for indexing different parts of the image. This way, when searching for a specific, for example, purse, you can find instances of purses similar to that one in a different context. This is much more powerful than finding similar images like Google Images reverse search engine does. The last one I'm going to be talking about is the aerial imaging applications. So in the age of cheap drones and affordable satellite launches, there has never been that much data of our world from above. There are already companies using satellite imagery and applying object detection to count cars, trees, and ships. This has resulted in high quality data which was impossible earlier, and now we're able to get it for broader audience as well. Some companies are also using drone footage for automatic inspections on hard to reach places or using object detection for general purpose analysis. Some companies are also adding automatic detection and location of problems without the need for human intervention. Of course, this comes with some problems. Let us look at some challenges that object detection faces. Firstly, the number of objects that can be detected in an image is a variable, which means that our output is variable. Now, why is this a problem? It's a problem because when training machine learning modules, you usually need to represent data into fixed size vectors. Since the number of objects in the image is not known beforehand, we would not know the correct number of outputs. So because of this, some post-processing is required, which adds complexity to the model. Historically, the variable number of outputs has been tackled using a sliding window based approach, generating fixed size features of that window for all different positions of it. After getting all predictions, some are discarded and some are merged to get final result. The other significant problem is the varying sizes of the detected objects. When doing a simple classification, you expect and you want to classify objects that cover most of the image. On the other hand, some of the objects you may want to find could be as small as a dozen pixels or maybe a very small percentage of the original image. that could be a little difficult, and tricky. If you look at this picture here, the bicycle is of a different size, and the car behind is of a different size, and the dog is of a different size. Traditionally, this has been solved with using sliding windows of different sizes. You go around the image with the sliders of different sliding windows of different sizes. This is very simple, but then it's very inefficient because you need various different sizes and you need to do the same operation on all of them. It increases the efficiency and the time it takes, and it increases the inefficiency and the time it takes, but it's a pretty simple concept as such to understand.